Alright, if you're a civil engineer, you know that concrete is, quite literally, the foundation of our world. But here's the thing, strength on day one means nothing if it doesn't last for decades, right? So today, we're getting into the real nitty-gritty of concrete durability, what it actually takes out in the field to build structures that are going to stand the test of time. I mean, just look at this thing. It's an absolute masterpiece. Structures like this are designed for a service life of over 100 years, but a design? That's just the plan. The real question, the one that probably keeps a lot of us up at night, is how do we make sure it actually hits that lifespan, especially when it's getting battered by the environment every single day. And that, right there, is what durability is all about. So here's our game plan. We'll start with why durability is so critical, the real stakes. Then we'll meet the hidden enemies that are working against our concrete. After that, we'll dive into the science of how things go wrong. I'll give you an on-site playbook, and we'll wrap it all up by talking about what this means for your legacy as an engineer. Okay, let's kick things off with the big picture, the stakes. And I want to be super clear here. This isn't just some term from a textbook. We're talking about safety, we're talking about money, and we're talking about reputation. Getting this right is completely 100% non-negotiable. Now, the American Concrete Institute (ACI) has this official definition, but let's just boil it down. Durability is simply your concrete's power to stand up to everything the world is going to throw at it. It's the huge difference between a structure that's still standing proud in 100 years and one that's already fallen apart after just a few. It's a simple question, but it's one that every single person on a project site, from the project manager to the person holding the vibrator, should be asking themselves, because the consequences, they're severe, and they ripple out way beyond just the job site. And here they are. It starts with the concrete losing strength, which obviously cripples its service life. That leads to repair and maintenance costs that just go through the roof. Then, of course, the reputation of everyone involved takes a massive hit. But the bottom line, the most important one, is that it creates a real danger to life and property, and that is exactly why this is non-negotiable. Alright, let's move on and meet the bad guys in our story. We're talking about concrete's hidden enemies, these constant physical and chemical threats that are, always at work, 24/7. Here's the great paradox of concrete. We think of it as this unbelievably strong, tough as nails material, and mechanically it is, but on a chemical level it can be surprisingly vulnerable. It's kind of like a heavyweight boxer, who looks unbeatable, but has a really weak immune system. Now, there are a bunch of ways chemicals can attack concrete, but these are the big four. You've got chlorides, which you see all the time in marine environments, sulfates from the soil and water. You've even got reactions that can happen from the inside, with certain aggregates, and then there's carbonation, which comes from the very air we breathe. For today, we're gonna zero in on that last one. So let's get into the science of it all. We're focusing on carbonation, because it's just the perfect example of a slow, silent killer. It's an attack that can have totally devastating effects down the line if we don't plan for it from day one. It all starts with the basic hydration chemistry, stuff we all learned. When cement and water mix, you get two main things. First is CSH gel. That's the glue, the stuff that gives concrete all its strength. The second thing is calcium hydroxide. And this part is absolutely critical. The calcium hydroxide creates a super alkaline environment. We're talking a pH of 12 or 13, and that high pH forms a protective passive shield around the steel rebar, which stops it from rusting. But here comes the attack. Carbon dioxide from the air, it just seeps into the pores of the concrete, and it reacts with our protective calcium hydroxide. That reaction starts to neutralize the alkalinity, causing the pH to drop. And once that pH falls below about 8.5, that protective shield around the rebar, it's gone. It's completely destroyed. And now, the steel is totally vulnerable, and corrosion is pretty much inevitable. This table really tells the whole story of this silent attack. Just look at these numbers. After 50 years in a standard M20 grade concrete, carbonation has penetrated 25 mm deep. But look over at the M40 grade, in that denser, higher quality concrete, it's only gotten 4 mm in. That is a massive difference. This is the hard proof that a higher grade, less permeable concrete is one of your absolute best lines of defense. It slows that enemy's advance to a crawl. Okay, so we've seen the threat, we get the science. Now for the most important part. What can you actually do about it? This is your on-site playbook. These are practical, actionable things every single engineer can and should be doing out in the field. Because let's be honest, a perfect design on paper is totally useless if it isn't executed correctly. Durability isn't just a spec number. It's forged right there in the dust and the noise of the construction site. It's built through the 1000s of small decisions and actions that you and your team make every single day. And here they are, your 5 golden rules. Number 1, use good quality materials. It's simple, right? Garbage in, garbage out. 2, ensure you have adequate cover to the steel. That concrete cover isn't just a number in a code book. It's the rebar's physical armor. 3, good construction practices. Every shortcut you take creates a future weakness. 4, proper compaction. Those little voids and honeycombs are open doors for water and chemicals, you have to eliminate them. And finally, number 5, generous curing. Curing is not optional. It is the single most important step to unlock the concrete's full potential for strength and density. These 5 keys are in your hands on every single job, and all of this brings us to our final point. Because when you follow these principles, you're not just pouring concrete. You're not just finishing a project. You are building a lasting legacy, and that is ultimately the engineer's greatest responsibility. I want you to just let this quote sink in for a minute. The ingredients of good and bad concrete are the same. Think about that. Cement, aggregate, sand, water. The raw materials don't change. The only variable is the knowledge, the care, and the commitment of the engineer standing right there on site. The difference is you. So as you head out to your site tomorrow, think about this. Every foundation you pour, every column you cast, it's a page in your professional story. These structures are going to outlive all of us. So the question you have to answer every single day is, what is your legacy gonna be? Will it be one of strength, of resilience, of durability? The choice is all yours. Thanks for watching. Like, subscribe, share,